Hello and welcome to a video about microscopes and calculations. This links to the Edexcel 9:1 GCSE Combined Science and Separate Science Biology specification. To begin with, I will be looking at the main parts of a light microscope and their functions. On this picture of a microscope, I have provided the labels for the parts that I would consider essential. Up here, we have the eyepiece lens. This is the lens that you would look through to view the specimen. We then have the objective lenses. These are of different magnifications. However, when initially looking at the specimen, you would start on the lowest magnification. The lenses are clearly marked with the magnification, as well as the length indicating the magnification. The longer the lens, the higher the magnification. The stage is where you would place your slide, and the stage clips would hold your slide in place. The diaphragm, which is under the stage, controls the amount of light passing through the image, which obviously is provided by the light source. The focusing dials are used to focus the image. This moves the objective lenses closer or further from the slide to do so. We then have the arm. The arm of the microscope is where you would hold the microscope from if you were moving it from place to place. And you could also support the microscope by placing your hand under the base. The purpose of a microscope is to magnify objects. By that, I mean making things look bigger. It enables us to see things that we normally could not see with the naked eye. Now, one of the things you may be asked to do in regards to a microscope is calculate the microscope's magnification. In order to do this, you would need to multiply the magnification of its lenses together. So for example, if this eyepiece here had a magnification of times 10, and the objective lens that we were using also had a magnification of times 10, that means the current magnification is 100 times 10 times 10. So you may have heard of the word resolution. It's often used when discussing microscopes. The detail obtained by a microscope is dependent upon its resolution. And in terms of what it means, the smallest distance between 2 points that can still be seen as 2 points. So if we look at the 2 points provided here, they are clearly two separate points. In a micrograph, these 2 points may be two subcellular structures. So if a microscope had a resolution of 0.0014 millimeters, then to see the 2 points as distinct points like this, it would mean the distance between them is 0.0014 millimeters or more. Anything closer than that value, then the 2 points would appear as a single point, as shown below. So for this example, we would assume that the distance between the 2 points is less than 0.0014 millimeters, thus seeing it as a single point. Best light microscope can magnify up to 1500 times and has a resolution down to 0.0001 millimeters. Electron microscopes obviously magnify much greater in comparison to a light microscope. They can magnify up to 2 million times. It has a resolution of 0.2 times 10 to the power of minus 6. So again, seeing things with a greater detail and greater clarity. One of the most important things that you must be able to do is convert between units. Units are quite important when using microscopes because we're obviously looking at images, measuring diameters, measuring sizes of components and so forth, and then we need to be able to convert between. So I have given you an example. I have provided us with 1 meter and then converted this 1 meter into millimeters. In order to go from meter to millimeters, I had to multiply by 1000. If I then wanted to convert from millimeters to micrometers, I would then once again multiply that value by 1000. And then micrometers to nanometers would also be multiplied by 1000, and then nanometers to picometers would also be multiplied by 1000. You need to know that if we were going in the other direction, then you would divide by 1000. So you might need to go from picometers to nanometers. So whatever your value is there, you would divide by 1000. It is really important that you can carry out these interconversions because, like I said before, they may give you some information in one unit and ask you to convert into another. You will need to be able to calculate the size of objects under the microscope, for which there is a simple formula. The formula used is magnification equals size of image divided by size of real object. As you can see, I've placed it into a formula triangle. It just makes it easier to use and clearer to understand what's going on. So if we look at this triangle, there is a division symbol there, and a multiplication between those two. So if I wanted to work out size of image, I would do magnification times size of real object. If we look at the example that I have provided, we can do the calculation to work out the actual diameter. We have been told that the cell measures 1 millimeter and the magnification was times 40. So the actual diameter would be 1, so size of image, divided by 40, which is magnification, giving us an answer of 0.025 millimeters. Again, looking at what I've been provided, they want the answer in micrometers. So to give me that, I would multiply this answer by 1000, which would give me 25 micrometers. So the size of the actual diameter of the cell is 25 micrometers. Lastly, you may be provided a micrograph and alongside be given a scale bar. These scale bars are used to estimate sizes. So looking at the micrograph provided, we've been given a scale bar that shows how long 4 micrometers is at this magnification. So roughly using this, I can estimate the size of this cell. What I would do, number 1, is take a ruler and measure from there to there, which I did earlier, and I know that the 4 micrometers equates to 170 millimeters. I would then measure the widest point of this cell from here to here. Again, I did this earlier. I know this is 430 millimeters in length. I would then carry out a very simple calculation. 430 divided by 170, which gives me an answer of 2.5. Because I know that the scale bar equates to 4 micrometers, I would then do 2.5 times 4, which will give me an answer of 10. This tells me that roughly this cell, and my apologies for that, I'm not sure why that happened, that this cell is roughly 10 micrometers long. Thank you for watching this video on microscopes and calculations. I hope that it has been of use and you have a better understanding. Look forward to seeing you in my next video.